So this is a video that is talking about the event trigger control. Conventional control, where there is a feedback system, the system output is being measured by the sensors and the sensor communicate to the controller, and as per the given strategy to the controller output is given to the actuator that drives the system to ensure that the controlled output should be maintained at the desired value. So in this feedback control system, xt is representing the output of the sensor, and based on the xt, ut is the controller output that communicated to the actuator, and actuator takes action onto the system. So as it is visible here that continuously the output of the sensor is available on the controller, and controller has to compile and compute the control action that should be given to the actuator. If it is based on the time triggered control, which is generally the kind of digital control, there is a periodic sampling of the sensor output. So here it is a fixed period. After a fixed period of the time, the sensor output is sampled, and that sampled signal is given to the controller, and based on that sampled signal, the controller is taking the computation of the control output which is given to the actuator, and actuator takes action onto the system to maintain the controlled variable at a desired level. So here the fixed time period is given, and that's why it is called the periodic control strategy, and the control task computation and its execution is done periodically at a regular interval. But here, if the sensors and the processors have a constrained energy, then the optimal usage of resources is limited, because after a certain time interval the computation should be done. Samplers are involved in the sampling, sensor and actuators are involved. To minimize that problem, to address that problem, the event triggered control strategy is being applied in the recent years, and that in this case the sampling is not the periodic sampling, and it is not done at a fixed period of time. So here what is the strategy? That the control tasks are determined by checking a pre-designed event triggering condition. So there is a triggering conditions here, fixed event trigger strategy has been designed, and the sensor output is communicated to the event triggered strategy block, and based on that strategy, the event triggered mechanism is allowing the sampler to work so that the controller can get the signal, and the controller will be getting the signal at a very not at a periodic interval, but it is getting the signal only when there is a certain predefined event triggering condition is met, and then the controller is computing is done, and then the actuator gets the signal to work onto the system so that the control variable should be achieved to the set points. But what is the event? An event implies that the measurement error between the current signal and the last sampled one exceeds a predefined threshold. So we need to carefully design the event triggering strategy, that what should be the strategy here, that is very important. And one fundamental thing that comes in our mind, that it can be an error between the current signal and the last sampled one, and if the difference of both exceeds some predefined threshold level, then only the sampler will be getting connected and the controller will involved in the computation process. So data are sent through the channel just when it is inevitably needed. It's not at the fixed periodic interval, but it is only at a certain time when there is a predefined error which is predefined with some strategy that crosses that threshold level. In the event triggering condition, there is a problem of Zeno phenomena that need to be taken care, and Zeno is a response of the system when there is a possibility that infinite number of triggering happen in a finite amount of time. So that is the challenge, and any event triggering control, if it is a task to design the event triggered control, Zeno phenomena should be avoided. So that's all about the event triggered control.